So here we have a calculator paper from the 2019 hire. What I'm going to do is I'm focusing on this question here, which looks at maximising and minimising surface area and how we approach this style of question using derivatives. Now it's a two-parter. First part is to show that the total surface area of the box given is this expression here, the equivalent of A equals 16x squared plus 4,000 over x. And what I then want to do is use this to minimise the cost of production based on the information given up here. So what I'm going to do is I first have to come up with some sort of expression for A, the surface area. Now we know the surface area is the area of all the outside faces of the box. So what I know is I've got 4 of these sides here, 34 there. I've also got a top and a bottom, so that's fairly straightforward, but I've also got to take into account the fact that I've got surface area on the inside of this tube, if you like, going down here. So I've got all that surface area I need to take into account. Now we're told in this that it's a cuboid and we're given information on the cuboid. Now the 4 outside faces are the same. So let's call these A1 for the 4 outside faces. So I know A1, so a single one of them, is given by length times breadth, so 3x times h, so that's 3xh. So that's each of these outside edges here. I know that the top, because it's a square on the top, it's 3x and 3x there. So let's call this A2. So it's going to be the 3x times 3x, so that's going to be 9x squared. But I'm missing this wee gap in the middle here because of this part that's been cut out. This has a square area here on top. Each side is called x, so it's going to be x squared. So it's going to be 9x squared, take away an x squared. So it's going to be 8x squared for what's there on the top. What I've also got to remember is the top and the bottom are the same, so my bottom is going to be the same as this. Each of the sides is going to be the same as this as well. What I need to calculate is the inner tube here, so the area of each of the faces here, and then I've got all the information I need to be able to combine them together and get some sort of an expression for the surface area. Let's call the inside face for one of these A3. And I know that because these are rectangular in shape, it's top times the breadth, so it's x times h, so it's just xh. So now that I've got all the parts for all the surfaces I can see, I can bring this all together and hopefully end up with this here for my surface area. So I know that my surface area is going to be given by 4 of the outside edges here, so essentially 4 of the A1s. So 4 of these, which gives me 12xh. I'm then going to add on a top and a bottom, so add on 2 of the tops and bottoms, so 2 of these A2s. So that's going to be plus 16x squared. I'm then going to have 4 of the inner faces here, so 4 of the A3s, so it's then going to be plus 4xh. So simplifying that, I'll end up with 16x squared plus 16xh. Good. So now I've got that. My 16x squared and this 16x squared match up. Great. This 16xh doesn't match up with the 4,000 over x. We've got this extra h in here, so we have to somehow get rid of it. We need more information to do that, and we're given it. We're told the volume of the box is the equivalent of 2,000 cubic centimetres. So what I can do is use this fact to eliminate the h somehow. Now, we know for the volume, it's length, breadth, height, but we've got this bit here in the middle that we've cut out. So the overall volume is going to be the volume of the big box, take away the volume of the wee box. Now the volume of the big box is given by length, breadth times height, so 3x times 3x times h. So what that then means is that 9x squared h, take away the volume of this wee one here, so x times h again, so minus x squared h is equal to the 2,000 I've been told in the question. Now if I simplify this, 9x squared h take away x squared h, that gives me 8x squared h is equal to 2,000. What I'm going to do is rearrange this such that I get some form of an expression for h. If I do that, take the ax squared across, what I'll end up with is h is equal to 250 over x squared. What I can now do is take that and substitute it into here. Based on that, I can then say fine, so my area A is given by 16x squared plus 16x times 250 over x itself. When we simplify x squared itself, when we simplify this, x and x cancel out here, leaving me with an x on the bottom, and 16 250s is 4,000, so I get 16x squared plus 4,000 over x, just as we wanted in the question. So there we go, I've shown the total surface area. Second part here is to minimise the cost of production, the surface area should be as small as possible. Find the minimum value of A. So minimising or maximising surface area, volume, any sort of property to do with shapes or anything we're looking at, looks at the derivative. Remember, derivative means rate of change. So to maximise and minimise it, I want to know where the rate of change is 0. So what I'm going to do is calculate the derivative of A, set it equal to 0, and solve it. So if I do that, so part B here, if I rewrite this as A of x equals 16x squared, but I'm going to rewrite the second term, I'm going to bring the x up here, so I've then got plus 4,000 x to the minus 1. So I'm bringing it all up here using the powers. I'm then going to take the derivative of that, so a dashed of x, and I'm going to say that fine, so that's 32x, take away 4,000 over x squared. And I know that for that to be the minimum value, that has to equal 0. So now what I want to do is rearrange this and solve it such that I've got this equal to 0. So if I stick the 4,000 over x squared across, I'll then be able to say that 4,000 over x squared is equal to 32x. Multiply both sides by x squared to get rid of the x squared on the bottom here. And what I'll end up with, I'm going to swap the sides again, so I've got the x on the left. So 32x cubed, because remember it's an x here and then an x squared, equals 4,000. If I then divide through by 32, I do 4,000 divided by 32, I'll end up with x cubed is equal to 125. So x is the cube root of 125, so x is equal to 5. So there we go, we've got a value for that. Now, what we have to do is we can't just take it on assumption that it is the minimum value, we have to show it is. So this is where our table of derivatives come into play. So what we have to do here is figure out what happens either side of x being equal to 5. So we know that at x equal to 5, our derivative is going to be 0, so it's going to be flat. I've just got to fill in the rest. Now, important thing to remember, what each row is. Top row is what the x is. Second row is the derivative. Make sure you put in the correct derivative though. In this case, it's a dashed of x, because we're looking at the derivative of the area. If you put a generic f of x in, you've plucked something out of thin air that isn't in the question itself. So what you have to do is make sure you put the correct context, i.e. the area, into the question. And then the last line here just looks at the graph. So if I look just below 5 at what happens to the derivative, so let's say 4 for example, and I were to substitute that into the derivative here, what I'd end up getting is 32 times 4, take away 4,000 over 4 squared. The value of that is negative 122. So the value below 5 is going to be negative. So my derivative is going to be negative below 5. What that means is my graph is coming down the way. If I then look at just above 5, so let's say 6 for example, and I was to substitute 6 into here, I'd do 32 times 6, take away 4,000 over 6 squared. That's the equivalent of 80.8 recurring. So it's a positive value in this case. And that means that my curve is coming up the way. So this value here at x is equal to 5, what we've discovered here is that it is a minimum turning point based on that information. So what I can then say is therefore at x equal to 5, we get the minimum value. What we then have to do is find this minimum value of a, and to do that we simply take x is equal to 5 and plug it into here. So we'd simply say that A is equal to 16 times 5 squared plus 4,000 divided by 5, which in this case is 1,200. So there you go, the minimum value of A. So quite a chunk of work to do for this sort of question here, looking at maximising and minimising values. However, it tends to follow the same routine, particularly when it comes to the actual maximising and minimising itself. This is a fairly standard type of question to get, particularly in a calculator exam, and would be considered about an A value question. Now when it comes to marks, part A is worth 3. In this one, mark 1 is given for getting to this stage here, the 16x squared plus 16xh. Mark 2 is for getting some expression for h, so getting some way of getting a relationship for h. And then the third one is substituting in for h and then proving it, so getting to this final one here. At this point, don't just assume, because you've got h is equal to that, and you've got this here, that you can then go and write 16x squared plus 4,000 over x. You have to show them substituting it in, so this line here first, and then getting to it by simplifying. You can't just jump to that final line. You have to show the substitution. Part B itself was worth 6 marks. First mark came from rearranging A to a differentiable form, so i.e. bringing the x up to the negative power. Second part was for taking the derivative and actually calculating it, and then the third part was for setting it equal to 0. Mark number 4 was working it through and finding a value for x, so x equal to 5. The next mark was for using a table of values or some other technique to prove it's the minimum. So for example, I could have used the second derivative of A at x equal to 5. What I found is that that's equal to 96, which is bigger than 0, so it's a minimum value then at that point. So I could have used that technique as well. Then once we've got it and we've proven it's a minimum value, getting the minimum value for the area is the final mark itself. Now bear in mind, as I mentioned before with the table of values, this has to be the correct format here. This has to be, in this case, a dashed of x. Put it into the context of the question. If not, you'll lose the marks for this, and you'll lose the marks for this last part here if it's calculating the area. So watch little intricate details when it comes to communication for that. Just watch these little bits. Try not to lose any marks. We want as much as we can out of these questions, and we want to make sure we walk away with our heads held high, showing that we know exactly what we're doing, because we can.